Hello students, myself Cam Rupnavar from Department of Chemistry, Tulsaram Chatuchanda College, Baramati, and I am teaching you a paper CHV 4101 Fundamentals of Physical Chemistry, in which we have already started section number 2 Kinetics and Reaction Dynamics. Here, today's lecture is lecture number 4, and in the previous lectures we have seen first chapter as a recapitulation in which we have learned or revised some terms as order, molecularity, rate constant, rate laws, and the different types of reactions as first order, zero order, and second order reactions, their equation, their plots, and the units. So, the main point in the chemistry or the kinetics is to note down the rates of any reaction. So, the rate of reaction is noted as the way which I am going to teach you right now. So see, today's topic is reaction rates. In the kinetics, before deriving any equation, before deriving any mechanism, the starting point is you have to note down the rate of reaction initially. Then and then only you can proceed further. So, in today's lecture, I am going to tell you how to write down a rate of reaction. The reaction will be simple reaction, it will be complex reaction. Okay, so see, here is the first example, and I have taken a general examples for your consideration only. So see, first example is A gives product and the rate of formation of product is K1 or rate constant is K1. So see, here initially at time t is equal to 0, A is 100%, and when there is a formation of product started, obviously concentration of A or the reactant A goes on decreasing. So, decreasing concentration, that means there is a minus. Initially 100% is there. Suppose 20% product is formed from this reactant A, then the reactant A concentration will be 80% and product is 20%. That means initial concentration of A goes on decreasing when the concentration or the amount of product goes on increasing. That means you have to write down a rate as minus D into concentration of A divided by dt. As we have defined, rate means the rate of change of concentration of any reactant with respect to time. So, here reactant A goes on decreasing to form a product. So, the rate of reactant is minus and the product is formed, its concentration going to increase or its amount is going to increase. So, increase is denoted by plus, amount is increasing. That is why the rate of formation of product is noted by symbol plus dp by dt. So, now we have to note down a rate of only of A or a reactant. So, we can note down dA by dt. This sign minus can be written either left side or the right side when only one reactant is there. You can write down this equation as minus dA by dt is equal to K1 into concentration of A, or you can write down the equation as the same way. dA by dt is equal to minus K1 into concentration of A, because see, this is a reactant with rate K1, it goes on decreasing to form a product. So, rate of reaction is K1 and concentration of A is going to decrease. Decreases, that's why here symbol is minus. And the rate of formation of product dP by dt taken as it is here. dP by dt is equal to C. Product P is formed from reactant A. Formation rate is there, that's why, or increasing the amount of P, that's why the rate is positive. And by which rate product is forming, so rate is K1. So you can note down here K1 into concentration of A. So from A with rate K1 the product formation occurs. That's why you can note down equation as dP by dt is equal to K1 into concentration of A. So this is a very simple reaction. A gives just only one product. There is no intermediate. So you can easily write down the equation as minus dA by dt is equal to dP by dt is equal to K1 into concentration of A. This is a simple equation or a simple rate law. Now the another example is here. A which gives B, and that is a reversible reaction. It gives again A. A gives B and B gives E. The forward rate is K1 and reverse rate is K minus 1. So now we have to write down a rate of this reaction. How you can note down the rate of this reaction? So see, here is A and product is B. So see, initially you have to write down the rates. So initially A is going to decrease to form a product B. So decreasing rate is noted as minus dA by dt is equal to dB by dt. But we have to write down a separate rate laws for A and B. So we are going to write down here dA by dt. As earlier I have told you, when only two constituents are there, A gives product or B gives product or C gives product, or only one reactant is there which gives product, at that time you can write down the minus sign either at the left side or at the right side when the concentration of reactant is going to decrease. But when there are two reactants, you can note down the minus sign to the respective term only, not to the left side. So I am going to write down here. So instead of this minus sign, you can write down rate. So we are going to write down a rate of reactant A. So just note down as dA by dt or d into concentration of A, which decreases with respect to time. So dt, d means change. So change in concentration of reactant A with respect to change in concentration of time. Rate of change of concentration of A with respect to change in time is equal to minus K1 into concentration of A plus K minus 1 into concentration of B. This equation I have written, but I am going to explain how this equation comes. So see, initially A is the reactant which goes on decreasing to form a product B. So decreasing rate and rate constant is K1. So initially decreasing amount, that's why minus sign. Rate is K1 and which term is going to decrease? So it is A. So first term comes minus K1 into concentration of A plus K minus 1 into concentration of B. So see, there is a reversible reaction and B goes on decreasing to form a reactant species A again. So B is going to decrease, but A is forming. So formation of rate is there, that's why plus sign is given. And by which rate A is going to form? So rate is K minus 1. And which species is going to decrease, so it is B. So rate is written as dA by dt is equal to minus K1 into concentration of A plus K minus 1 into concentration of B. So C, always write down a term in concentration bracket which is going to decrease. Now dB by dt is equal to, so see, we are going to write down the rate for this product B. So see, initially B is forming and A is going to decrease. So formation rate is positive, so plus K1, and by which species B is going to form? From A. So we are going to write down here A, K1 into concentration of A to form B. Then next term is B is going to decrease. Decreases, that's why minus sign. By which rate it is going to decrease? Rate is K minus 1. And which species is going to decrease? It is B. So here rate is written as K minus 1 into concentration of B for the reverse reaction. So overall rate of B species is dB by dt is equal to K1 into concentration of A minus K minus 1 into concentration of B. This is our rate for this equation number 2 or the problem number 2. Now next problem is problem number 3. Here A gives B and B gives product. So see, B is the intermediate species here. So first rate is K1 and second forward rate is K2. Here two rates are written. So we are going to write down the rate for each species A, B and P. So we have three equations. So we have to see first in which steps our species is involved. So see, A gives B. Only one step is there. That's why dA by dt includes only one term. So dA by dt, or the rate of change of concentration of A with respect to time, is equal to minus K1 into concentration of A. So A going to decrease, that's why minus symbol is here. By which rate it is going to decrease? It is K1. And which species is going to decrease? It will be A. So only one term is involved because in one step A is present. Then the second rate is for B species. dB by dt is equal to, initially B is forming, formation rate is positive, by which rate it is going to form? By K1 rate, and by which species it is formed? So from A it is going to form. So written K1 into concentration of A. Next step is here. In second step, B is going to decrease to form a product. So it is decreasing, its volume or its amount or its concentration going to decrease. Decreases, that's why written symbol minus. And by which rate it is going to decrease? Rate is K2. And which species is going to decrease? It is B. So written minus K2 into concentration of B. So overall rate is dB by dt is equal to K1 into concentration of A minus K2 into concentration of B. So this is the equation number 2. Now we have to write down the rate of a formation of a product. Formation rate is positive and decomposition rate is negative. That's why here product is forming. So we are going to write down rate for this. So rate of change of product formation with respect to time is equal to K2 into concentration of B. This is our equation number 3. So our next example is A gives B. B reversibly gives A. From B species there is a formation of product. So see here, this reaction is a complex type reaction. A gives with rate K1 B. Then B gives with rate K2 product, and here B species again gives A and rate is K minus 1. So forward rates are written as K1, K2, K3 and so on, and reverse rates are written as K-1, K-2, K-3 and so on. So this is the equation and we have to write down the rates of dA by dt, dB by dt and dP by dt. So see, A species is involved in two steps now. A gives B and B gives A. So two steps are there. So now we are going to write down the rate of A. So dA by dt is equal to, initially A is going to decrease to form B, and the decrease rate, that's why minus symbol is there. Rate constant is K1 and which species is going to decrease? It is A. So minus K1 into concentration of A. But by second step it is again forming. So formation rate is plus, by which rate it is going to form? By K-1, and from which species it is going to form? From B. So this is the rate of change of concentration of A with respect to time, which is equal to minus K1 into concentration of A plus K-1 into concentration of B. Then the next term is B, or the next intermediate is the B. So dB by dt, or the rate of change of concentration of B with respect to time, is equal to, so B species is forming from A. So formation rate is positive. By which rate it is forming? By rate K1. And from which species it is going to form? From A. So K1 into concentration of A. Minus, again B is going to decrease to form A. So by which rate B is going to decrease? By K-1. Decreases, that's why minus sign. Rate is K-1. Which species is decreasing? B. So written here B. B involves in three steps, that's why. B gives product. This is the third step. Here B goes on decreasing to form a product. Decreases, that's why minus symbol. Rate is K2, and which species is going to decrease? It is B. So minus K2 into concentration of B. So this is the equation. dB by dt is equal to K1 into concentration of A minus K-1 into concentration of B minus K2 into concentration of B. This is our intermediate, and last step is dB by dt, which is equal to K2 into concentration of B. So see, product is formed by rate K2 and the species which goes to decrease is B. So rate is written as dP by dt is equal to K2 into concentration of B. Now our next example is A gives B, B gives C and C gives product. Here A gives B with rate K1, from B again A forms with rate K-1. B gives C with rate K2 and there is a reversible reaction and rate is K-2. And from C species product P is formed and rate is K3. So see here 4 steps are there: A, B, C and P product. So d by dt is equal to, initially A is going to decrease to form B. So minus K1 into concentration of A. This is the first step, plus with K-1 rate B is going to form. So this is our first equation. Same way you can note down dB by dt. So dB by dt is equal to, with rate K1 it is formed from species A. So formation rate is positive. K1 is the rate and the species which goes on decreasing to form a product is A. So K1 into concentration of A minus, because B species is going to decrease to form A, so minus decreasing rate is K-1 and species decreasing is B. That's why minus K-1 into concentration of B minus this B species involved in next two steps also, minus K2 into concentration of B. Then from C species it is again going to form. So, and the formation rate is written by plus sign, rate constant is K minus 2, and the species which goes on decreasing to form a product P is C. So, written as K minus 2 into concentration of C. So, K1 into concentration of E minus K minus 1 into concentration of B minus K2 into concentration of B plus K minus 2 into concentration of C. This is the rate for species V. Then same way you can write down this rate for C and rate for product. Here rate of change of concentration of C species is given by, this is forming from B by rate K2, formation rate is positive and rate is K2, and which species is going to decrease to form C? This species is B, minus this species is going to decrease to form B. That's why minus K minus 2 is the rate and the C species is decreases. Then with rate K3 the product is formed from species C. C species is going to decrease to form a product. Decreases, that's why minus symbol, rate of decrease is K3 and C species is going to decrease. So, in minus K3 into concentration of C. So, overall rate of change of concentration of C with respect to time is equal to K2 into concentration of B minus K minus 2 into concentration of C minus K3 into concentration of C. Then last one is the rate of formation of product. Formation rate is always positive. Therefore, dP by dt is equal to, by K3 rate it is formed and the species from which product is formed is, the species is C. So, just dP by dt is equal to K3 into concentration of C. This is the equation for product formation. Then our next equation, again this is example of a complex reaction. Here or the zeroth order rate law of a thermodynamics or zeroth law of thermodynamics. Here the thermodynamics law is when A is related to B, B is related to C and C is related to A. Means all three systems are in equilibrium with each other. They are interrelated. So, see, as same way, here is the example. Here three species are given. A gives B, B gives C and C gives A. But there is each time a forward reaction and the reverse reaction, and you have to write down a rate of species dA by dt, dB by dt and dC by dt separately. So, see how we are going to write down a rate of this type of reactions. So, initially you have to write down the rate of formation of dA by dt. It will be either formed or either going to decrease. So, just note down a rate for species A, dA by dt, which is equal to. So, by you are writing a rate, you can move towards the clockwise direction instead of the anti-clockwise direction. So, I am going by the clockwise direction. So, see, A gives product B and the rate is K1. So, initially A is going to decrease to form B. So, K1 into concentration of A and A concentration decreases to form B. So, minus K1 into concentration of A. This is our first term. Then there is a reversible reaction with rate K minus 1. A again get formed from species B. So, formation rate is positive, rate of formation is K minus 1, from which species A is formed? From B. So, written here plus K minus 1 into concentration of B. Again, here is the next step from C to A and A to C. So, from C with rate K3, A is forming. So, you can note down here plus K3 into concentration of C. Then there is again a reversible reaction. So, A goes on decreasing to form C. decreases, that's why minus symbol. With rate k minus 3, it goes to form a product C, that's why minus k minus 3 into concentration of C. Here K1, K2, K minus 1, K minus 2, these are the symbols only. Then by same way you can write down rates for dB by dt as here base formed initially by rate K1 from A, therefore formation rate is positive. K1 into concentration of A, then it goes on decreasing to form repeatedly A, therefore decreasing rate is minus. With rate K minus 1 it goes on decreasing, and with species is decreasing B. So minus K minus 1 into concentration of B minus, in this step it also involved, that's why with rate K2 it goes on decreasing to form species C, therefore decreasing minus sign, rate is K2, and with species is decreasing B. So written here as minus K2 into concentration of B. Next by K minus 2 rate it is again forming, formation rate is positive. K minus 2 is the rate, and from which species? Base form C species, therefore plus K minus 2 into concentration of C. So see here dP by dt is equal to K1 into concentration of A minus K minus 1 into concentration of B minus K2 into concentration of B plus K by this 2 into concentration of C. By same way you can write down the rate of dC by dt. It is forming from K2 rate from B, therefore K2 into concentration of B. It is again going to decrease to form B, therefore decreasing. K minus 2 rate is there, and which species is decreasing? C. Minus with rate K3 it is decreasing to form A, so therefore decreasing rate is there, therefore minus rate constant is K3, and C species is decreasing, so written as minus K3 into concentration of C plus K minus 3 into concentration of C, because with rate K minus 3 C species again forming, so rate is positive. K minus 3 is the rate constant, and concentration C is increasing. By same way you can write down the rate for this. Here A gives B, B gives C, C gives D, and here only A to B and C to D, there is a reversible reaction, and you have to note down the rates of A and D only. So see, here is one change. Here all the terms are correct, but here instead of C, in the last term you can write down A, because C species is forming from A. That means A decreases, and our rule is the decreasing species is written in this bracket only. So A decreases, so here only you can note down A. So please try to solve all the examples and solve this problem.